And so, although you're working on this assignment for Monday, multiple regression analysis here, and you may be working together, I expect you guys to understand individually what you're doing because you're going to have to apply the techniques to your analysis. Not exactly the models in this assignment. You're going to have to use the models given by the theory for your research project. Okay, and you're going to have to improve your model and explain in some sort similar fashion how you've improved your model, providing several regressions. We had 8 models. I don't know what it's going to take, but you're going to have a few models. Maybe I'll decide as I see how you guys progress by then how many models I want on July 11th, okay? So I don't know what happened with the upload from last class, but it froze. So I am going to have to re-upload that after the class, or I'll take a break or something and do it. Okay, so today, do you have any questions for me? I was going to continue with the regression models. How many of you have made progress on the regression models or the videos? Have you made progress on the regression models and the videos? Let me know in the chat. Let me know in the chat. Okay, Morelli. Oh, Robert, you watched them all, and you can watch them again, and you might refer to them again. So, um, don't hesitate to repeat them. So, how about your progress with the assignment? How far are you? Which model have you completed? You guys haven't worked on the models. So, you want me to work on the models? Well, I mean, I'm going to work on the models, but you want to see that? All right, we are on model 3. If you watch the videos, it will speed things up in your understanding. That's it? You guys are not doing your homework? Okay, so Noelia, if you watch the videos, they're all modeled in the videos, so you'll find out. Okay, it's all in the videos. I just expect you to reproduce it. Okay. Okay, Noelia, so watch the videos and you'll see. But we'll do it here as well. Thanks for letting me know, and thanks for progressing independently. Or maybe you're in a group. So by Monday, I have to let you know how I'm pairing you together for the deadline on Friday. And I also want to tell you on Monday what I expect from you because I want you to do those 3 components, but I need to tell you what I want in that. Like, you did a literature review, you sent it to me with 10 papers, and looking at them, a lot of those papers are irrelevant or okay, let me tell you this. In terms of your literature review for your papers, hold on, let me get you back on the screen. There. Um, in terms of the literature review for your assignments, you guys put in papers, some of that are academic articles. I asked you to get the journal quality. That would have told you checking in ABDC or using publish or perish or finding some way of evaluating your journal. one of those ways of evaluating your journal, or I don't know, some other way, you know if it was a good article or quality article. All right. If it's not in the list, or if you're having trouble qualifying it, let me know and I will help you, because you need to use journal articles. 80% of the references that you use in your final paper must be academic journals. The other 20% can be articles that are in trade journals, maybe, or websites, or Economic Bureau of Statistics papers, okay? So 80% have to be journals, academic journals. Got it? Does everybody understand? All right. Okay, so let's go back to our models. So we left off with this, we ran this model. So I was explaining that we can see the relationships between the y and each of the variables age and odometer, and we see certain curves that we want to explain, and we want to account for in our model. So to do that, for age, we know there was a parabola looking up, right? A happy face parabola, happy face curve. So we included h squared, and we have to put age into the model y. If you watch the videos, who knows why we have to put age into the model? Did you see that? So we have to put age and h squared. We can't just put age squared, because age will allow us to capture if the center of the parabola is on the y-axis or on the vertical axis or not, okay? So let's move it around off the axis. And then we include log odometer, because this is also explained in the videos, because log takes a skewed or stretched out or really spread out variable and tightens it up. Okay, so that's what's going to happen there. So because we like to see our variables, the relationship should be between the x and the y, you know, whichever x that we use, whichever explanatory that we use, and the y should be sort of linear, right? And that means that each of the values should have relatively symmetric, you know, the variable, the explanatory variable, or the one that we use in the model should have a normal distribution, or symmetric, at least a symmetric distribution, okay? And then if it's really spread out and you have, remember, we're seeing some graphs and the data just like kind of funnel, like opens up like that, or it goes down like this. That's what you want. You want it to be even, right? You want it to be even trend, whichever way. All right, so I posted also some of the notes that I introduced you to the economics. Remember, those are just reference. You don't have to study those for a test or anything. Those are reference notes that can help you, ground you in regression analysis in a discipline that you should know, economics. So you don't have to know, you don't have to read the whole thing. It just embedded in there are the discussion points that I made last class. Okay, so let's we have that model in number 3. Did we put it? No. I feel like this was a 1 over. Okay, so we're going to run this one. And it's going to go into model 3. We're going to put log of odometer. Oops, that's not what I wanted to do. I wanted to move over. Sorry. So let me make sure, okay, you guys see the thing. I wanted to do this. So as I'm doing it, you guys can do it too. You can tell me to slow down. At least we can have the work done at the same time. So I want age, h squared, and log of odometer. Okay, so that I have those there. Here. I'm going to move this over. I'm going to insert and move that over. Paste special and values paste. So you keep the values, maybe not the formula. And then highlight tools, data analysis, regression, model 3. Make sure that it's entering the right. For the Y, it's going to be column B. For the X's, the explanatories, it's going to go up to E. Put the labels, output range model 3 sheet, and we can get these plots. Oh, it won't let me do it on the named one. Okay. It needs to go onto a new one. All right, that's fine. Let me erase this. Excuse me for a second. I'm going to delete that blank sheet and call this model 3. I'm just naming the tab. And I have all my graphs over here that I can click and shift and move all of them over. Take everything that it can give me. Get them out of the way for now. Spread this all out. Well, at least these. Okay. Make it bigger. Okay, everybody's got it. And we're going to do the same interpretation, similar interpretation as before. Save the document. Where do we start? Where do we start? Who's going to tell me? Anybody? Where do we start? Where should we start? Well, let's compare back to 2. So for the second one, we had, oh, this is, I have so many versions up here. Okay, we did model 2 together. Different. Okay, well, where do we start? Let's start with the R square. So in model 2, the R square, adjusted R square was 57%. In model 3, it's 60% adjusted R squared. Okay, so it improved slightly, not a lot. But let's see if the meaning of the variables, if they have the result we expected. So we can say here, so we'll just write from the, you can do it from the R square or the adjusted R squared. I'll do it from the R squared. 61% of the variation in price is explained by the model or the 3 independent variables. So it's improved. what we really want to look at is the R squared, or the adjusted R squared, because that adjusts for just adding, the effect of adding more variables will always increase the R squared. So we want to adjust it that it's not just getting bigger because we added more variables, that it's actually improving the model. So I can just use that one here, but I'll move it down. I'm debating because this is the one you learn about a lot, but this is the one we interpret. It's the same thing. All right. I mean, this is not the same thing. It's an improvement for picking your models, between your models. All right, so then here we go here, and what does this tell us? This is the result of the null hypothesis test that, okay, so all coefficients, estimates, no, all coefficients are 0. But this result is a p-value for the f-test that's smaller than 5%. Okay, so this actually has, this number is 1.02 times 10 to the negative 19. So it has 18 zeros in front of it. So it's a very small number. This only has 1 0 in front of the 5, right? So this is a very small number. It means that there's a small chance of seeing what we saw. As a result, something's wrong. What's wrong? We reject our assumption. So at least one of those coefficients, not coefficient estimates, coefficients are 0. So one of our coefficients are not, at least one are non-zero. In fact, when we look at our individual tests and their p-values, we see they're all smaller than, so p-value here, all are smaller than 0.05. Okay, so all are smaller than 0.05. So that means they're all statistically significant. Okay, now let's look at the meaning of them. So we're going to start here on h squared, and at the end of the last meeting, we discussed what we expected here from the plot, right? We wanted to capture the curve, the parabola that was facing up. So the square term should have a coefficient in front that's a positive, right? To capture that parabola going up. And it is positive, it is significant. So we've done it, we accomplished that. And now we have this one. So let's write up what we have. In terms of h squared, sorry, 1 second. All right, so if you watched it in the video, so you guys, not many of you got this far, but please watch this in the video, you're not going to understand. We can interpret this as we did before in the other models. Can you guys write how you interpret h squared and how you interpret log of odometer? Can you guys put that in the chat? Base it on what you did last class with the last Excel. Anybody? Nobody? You guys have no idea? Okay, no comments. All right, so you guys did not watch the video. So what we're going to do is we're going to interpret log of odometer. So how did we do it last time? We said for a 1 unit increase in that variable, log of odometer, and just read the variable off, right? Price decreases negative $1,079. That's how you read it. But you feel uncomfortable about interpreting it like that because what is log of odometer? We also have to add on holding age constant, right? Holding age constant. So on average, at every level of age, if for 1 unit increase in log of odometer, the price goes down. So that's what we expect. But now we want to interpret it in odometer, log of odometer. So when we use natural logs or logs, it's a nice, it's actually a nice interpretation, and you need to remember this because you use natural log a lot in economics and in finance regression. So this is actually how we interpret it. For a 1% increase in the odometer, price decreases by 1079, you could say 0.4 divided by 100. Or how much is that? 1079. So you've put it back into the original variables, which is more understandable. And when you use log, when you log explanatory variable, it converts the interpretation in this way. I'm going to throw the on average in there, age constant. So for every level of age, we've got an average, and I'll put it in here too. On average. Okay, so this is the better interpretation. We do the same sort of thing for age square, where we interpret it like this: for a 1 unit increase in age square, price decreases by 6. But again, it's not simple to understand. So in fact, usually all we do, we don't go that far. We just look at the sign, and we're just like happy with the sign, and we don't even interpret the sign of age or the value of age. We're just looking for the sign being correct according to our theory, like our underlying idea that it should be parabola facing up. Okay, so that's the relationship. That's what how you're going to interpret it. Just giving you an idea how to interpret your output. This is an improved model with an adjusted R squared. 60% of the variation price is explained by the 3 independent variables. Even though the function is not linear, it's a curve here and it's a logarithm there, it's linear in the coefficients, because we just have the coefficient as, the coefficient for age, the coefficient for age squared. So we create a variable to capture that coefficient. So it's linear in the coefficients. We're just adding across, creating new variables from the old ones. All right. So that's what I wanted there. Questions about this? So this is how you interpret when you have a logged variable. What we're going to do for the next model, let me save that. I think I didn't save the one that we did the last class, so that's not good. The third model was this one. Our fourth model we're actually going to log the price. Now that's going to be a new interpretation as well. And this also is very common with economic data, finance data, well, data in general, that you have this spread out. So it's very spread out. We want to tighten it up. We want to normalize it, make it look more symmetric. So we're going to actually log the price variable. So can you guys go ahead and create a log price variable? And then I'll show you how to interpret that. Oops, why do I keep shrinking? I grabbed the wrong edge. All right. So let's see if let's plot in our plots, right? When we got our curves, we're going to account for that by logging price as well. So we're going to create a log price. I'll just do it right beside it. So you create the function. Everybody's with me? Double click, and there you go. So you see how these numbers are very spread out, but look how close these are together. So it tightens things up. Okay. All right, so now we're going to do this 3. We still expect this one to have a positive coefficient for h squared. You expect them. We hope they're all significant. And let's look if our adjusted R-square is better. So tools, data analysis, regression, model 4. Let's name it model 4. So it opens in a new sheet, not a new workbook, new sheet. Make sure I got everything. Aha, look, we got to fix this because this is still on B. We need to make it, put it on C. Put it on C. And then you want to go D to F. Oh, wow, it didn't care what I'm pretty sure I highlighted. Anyway, I don't know what happened. Make sure it works. Oh, no, D to F. Thought I highlighted it properly. And say OK. Highlight holding the shift curve down. Oh, this is worse. Did I do it right? Let me do it again. Let me look. Let me see. Looks like I did it right. Yep. Okay. So it's just worse. But I want to teach you the interpretation at any rate, because you need to know that as well. So move that over. Make these spread out. So you double click there, it spreads it out as it needs it. Make it more visible. There we go. Let's write out the model. I didn't do that last time, did I? In X3. Let's do it in X4. So we got to write out the model in X3. So the model here is price, or Y. We can say Y. We know Y is price. Is equal to 11,863. We didn't interpret the intercept either on this one. So this is like 11,863 plus or minus 365. I'm just going to round them. So 356 H or X1 plus 663 or 6, no, I'll just write 7. X2 plus minus 1079x3. That's the model there. And so I reduce, referring to age as x1, age squared as x2, and 1079 as x3. Let me save that. And let's go to model 4. Let's do the same thing. Oh, I can get rid of the dollar sign. I don't know why I put it there. Got excited. So just put it there. Like that. Let's do the model for number 4. The model here, if you look at the adjusted R-square, it's worse. It went down. So this is not a better fit. But I still want to do the interpretation because I'm teaching you how to do these interpretations. So here y is equal to, or y hat, sorry, let's go back. Let's put y hat there. It's because it's a prediction line. It's not all the scatter is actually sitting on the line. So y hat on model 3 as well. So y hat is equal to 9 plus, sorry, minus. Okay, I guess I have to use decimals because everything's small. So I'm going to use 2 decimal places. 9.39. You don't want to have a bunch of zeros because we're trying to say things are non-zero, right? These coefficients are non-zero. So, let's write that. Let's look at how we write this. Here, give me a break here. Okay, so this one is the smallest one. And we need to write 4 decimal places to actually get a non-zero number. So we want to write it like that, okay? Because just scanning this is the test is significant, meaning that not all of the coefficients are 0. At least one is not. This tells us they're all significant. So, a non-zero. So, not just one. So I don't want to put a 0 in my equation. Okay, that doesn't make sense. So I'm going to have to put 4 decimals in all of them to be consistent. So let's do that. So 9.3916 plus, you guys with me? Minus 0. Minus 0.0544 x1 plus 0.0008 x2 plus, or I can round it to 3. Okay. Well, let's just leave it like this for now. But I could have rounded it to 3 because I could round up 0.0008 to be 001. All right. But anyway, leave it like this for now. I made enough changes to it. Minus 0.1971 x3. Okay, so that's the model. Okay. That's the estimated. It's the estimated model. Those are the estimated coefficients of the true model that we hypothesize. Okay, and so our interpretation, if we interpret all of them, which I expect you guys to do, okay, I'm going to ask you guys because you guys are not eager to speak to me. I'm going to ask you to tell me. I'm going to make this easy for you. Okay, Raul, intercept. Are you there? Give me the interpretation of the intercept. Oh, he's not here today. Okay, Jared, give me the interpretation of the y-intercept. You can put it in the chat if you want, or you can say aloud. Anybody? Oh, he's writing it? Okay. Anybody else can write the other ones? Any of the other interpretations? It's a trick question. What is y hat here? Kind of tricky. What did we do here? Let's go back and see. What did we do? What did we model? Don't write it here. Where did I write? What happened to my models? Oh, they're up here. Right. I don't. Jared, I don't hear you. Okay, very good, except it's not price anymore. Yeah, you did well. Okay, so he said, when age, I've got to copy it. I'm going to copy it to the model 4. When age square, and lawn odometer are 0, price is 9.39 on average. Very good. Not price though. What was the Y again? The log of price. Okay. So you did great. You got 9.5 out of 10 points on that. Yeah, very good. So it's like long price with a hat on it. Okay. So when age square, and lawn odometer are 0, price, so you say lawn price, ln price is that. Okay, so it's weird with the ln thing, okay, but it helps us get to another level of interpretation and modeling that I really want to show you. We can continue with this kind of interpretation for a 1 unit change in age. The log price goes down 0.05. Again, whatever that means. You see, all the numbers are smaller because we're working with lawn of price, and that puts all the numbers, it squishes them together, puts them closer together. Same thing here, age square, and lawn odometer. So I'm going to leave those ones for you guys to do. You're going to have to answer all of those. So I want you to do it for age square, and I'm going to do this one because this is new. Unless anybody wants to ask me what these ones are, I'm going to do this one because this one's new. So how do we interpret lawn odometer? We say, because we're doing a log, to remember y hat is long price. Y hat is long price hat. We actually say a 1% increase in the odometer reading decreases the price by 0.197%. So this is actually lovely because now we can talk about percentages. Okay, and interpret it back in the normal, the regular, in the actual regular, this looks weird, variables that we understand. So this is a common transformation that interprets really nicely. A 1% increase in the odometer reading decreases the price by 0.197%. On average, holding age constant or the other variable constant. Oh, we didn't say that here either. Yeah, on average. Okay. So we're just holding age constant because, well, that's the only other variable, really. You guys getting that? So I expect you to interpret all of them. This is the new thing. When you have log explanatory variable and you have log of the y, you can make up interpretation like this. Any questions? Okay, we have a little bit more time. Okay, great. Oh, Raul's back or here or something. Okay, so let's go to the fifth model if you don't have any questions. What's the fifth model? That was bad, right? I didn't even go into the rest of the interpretation, but I do expect to see that on your assignments. The F is okay, and the adjusted R square is worse. So we're going to try and include a new variable. Okay, the new variable, pink slip, is, I guess, the terminology for your car passing the like the, what is it called? Safety? The safety. Does it? The safety. The safety test. So the pink slip is passing the safety test, I believe. And so, wow, what do you think? Either it passes the safety test or it fails the safety test. If it doesn't have the pink slip, it means it failed the safety test. So is the car going to be worth more if it has a pink slip? It should be, right? If it doesn't have the pink slip, it should be worth less. So let's put that extra information in. We're going to stick with we're going to continue with the y being log price and see if we do any better with our model. So this is the fifth model. We're going to add in the pink slip. Now the pink slip is different from the other variables. How is it different from the other variables? What kind of variables are these variables? What kind of variable? What do we call these variables? Price, age, odometer. Those are known as continuous variables, right? Or continuous. So they're quantitative and specifically continuous variables. So all variables up to model 4 are quantitative continuous variables. Pink slip is what kind of a variable? Is it quantitative? No. What's the name of pink slip type of variable? Right. So Raul says it's qualitative. So it's either called a qualitative or categorical. Okay, let's say it like this. Yeah, it's qualitative or categorical. Let's say it like that. Categorical. I like to say categorical usually because qualitative sounds like quantitative and can be confusing for some people. So we call it categorical. Categorical because either it passes category 1 or it fails category 2. Now there's two types of categorical variables, broadly speaking. Do you guys know what the two types of categorical variables are? Okay. So, okay, let's go back to quantitative. There's two types of quantitative variables. I'm putting this in the chat. There's two types of quantitative variables. What are the two types of quantitative variables, first of all? Continuous and discrete. So, continuous are the ones that can have decimals, and discrete ones are whole numbers. Okay. There's also two broader types of, because you can make more specifications, but two types of categorical variables. Nominal and ordinal. Thank you, Raul. Okay, there are two types of categorical variables, nominal and ordinal. What kind is pink slip? Nominal or ordinal? It's important that you understand the types of variables you're working with because not all regression analysis can use any variable. You have to know what variables you're working with, the classification of the variable for the interpretation in a regression. Okay, Raul is wrong. Once in a million. Not ordinal. You can maybe debate that it's ordinal, I guess, because it's better. Seems like it's better. Right, right. But you're putting a judgment on it that it's better to have its yeah, pass the test, or how did he say? Yeah, that it's you can put it back on the road than just have it be parts of the car. Because you can't put it back on the road or you have to repair it before you put it on the road. But we're not going to do any of that. We're just going to say that the number value for our calculations, ordinal interprets as the number itself in our computations has particular meaning. I know this is hard to explain with a 0-1 variable. So another name for a 0-1 variable is binary. So what pink slip is a good call, Raul. Okay, you're not exactly off. You're on track. I get it. Yeah, the number has to have meaning for it to be ordinal, and like the distance between the number has to have meaning, and it's a different kind of analysis you do. Anyway, it's not going to be such of a big issue, but as you're reading papers, you might hear this terminology, so I want to go through it. So pink slip is actually a categorical nominal variable, also known as binary, or sometimes it's called, what's it called? Well, it's called nominal. A binary dichotomous. That's the word I'm looking. Dichotomous. So you might read those kinds of terms. Oh, another one is indicator. And another word would be binary dichotomous, indicator, or dummy. You can hear about dummies. And then maybe there's other terms I'm not coming to mind right now, but those are them. So binary dichotomous, indicator, dummy. It's an important variable. It's not dumb in that sense. It's dummy as though it's flagging you. It's telling you, you know, it's nudging you. Okay, this one is different. This observation is different than the others in a specific way. All right, so how do we model pink slip, and how do we interpret it? Let's see if we can get through more models. Let's put it beside, I know I'm kind of making a mess with my Excel sheet, but I'm being honest with you. That's how I do things. Make a mess and then I clean it up later. Okay. So our model is gonna include all of these, which are transformations of age and odometer. And now we're going to include pink slip. Okay, let's do this. Highlight, insert those tools, sorry, data analysis, regression, okay. Make sure it selected all the right columns because I don't know what happened last time. Yeah, it didn't do it. So it keeps jumping back for some reason. Let me try it again. I don't know why. It doesn't do what I want. You guys can maybe figure it out. So tools, data analysis. I'm just going to try one more time. Nope, it doesn't want to. It doesn't care what I want to do. So let's just put in the letters. It's better than having to highlight one by one. So D all the way down is my Y, and X starts at E and goes all the way to E, F, G, H. E to H. I'm not sure why it's doing that. Model, we're on to model 5. We want all our plots, labels, and everything. There we go. Okay, our adjusted R-square is still terrible. We'll work on, we're just working with Z-stat videos, an explanation to learn about these transformations, but these are not great fits. This went down. Actually, is it better than 4? It's like, didn't do anything. 3, 4, 1, 9. So, oh, it's worse. Okay, so pink slip doesn't add anything. And you see it doesn't help the R-squared if it doesn't add anything. So what do I mean doesn't add anything? You see the significance is, yes, okay. They're not all 0 except pink slip. So pink slip, this coefficient is considered not different from 0. You see why? Because this is the coefficient, but then if you take it within 1 standard deviation, so if you take this and you add, or standard error, you add the standard error and subtract it, you're already crossing 0, right? It's going over 0. So this number is not different from 0, and that's what you see here. P-value is not small. It's not unusual. In fact, there's 38% chance of getting this result if the null hypothesis here, that the coefficient is 0, is true. So it's not weird. And that we got that it's the hypothesis is true. It makes sense. So this is a 0. It doesn't add anything. In fact, it's a slightly worse adjusted R-squared. But I want you to interpret it anyway, because I want you to practice interpretation. So you're going to interpret h squared the way we did before, logodominant the way we did before. How do we interpret pink slip? Let's interpret pink slip. And how do we write the model? We'll go back with the model. Right, so this is what we did for model 4. We do the same thing for model 3. And we just do the x1, x2, x3, which represents these here. So these ones need to be interpreted. And I'm going to jump to pink slip. And what do we say? Anybody take a stab at that? Again, it's not significant, but we're going to do the interpretation just so that we're practicing interpreting different kinds of variables. Now this one being categorical. What would you write? It's positive, which makes sense. So if pink slip is 1, that's how you say it, okay? It's because 0 or 1. So if pink slip is 1, what does it say? Maybe if I write the model, it helps. I don't know. So I'm going to write ln price hat is equal to 9.23 plus, notice that things didn't change too much. Maybe I can just copy from what I did before because it's pretty much the same model. It didn't change. Adding that in, not significant. It didn't do too much. Let's put it here. And verify. I hope you guys are watching. You want to have a nice weekend. Okay, so it's slightly different here. So 92371, but very similar. And then negative 0.0515. It didn't change, see? 0.0008x2, and then negative 1981, and then positive 0.1558x3. x4. There you go. So let's interpret pink slip. Anybody? Nobody? Nobody. So if a car has a pink slip, that's all you say, because it's either a pink slip or no pink slip. So if a car has a pink slip, the price increases, not price, the ln price increases by 0.1, oh, 0.16. Whatever that is. If we if we wanted to invert that, what would that be? What would be the price? If it's long price increases 0.16, what about price? How would we adjust that? Does anybody know? What's the relationship? Anybody want to guess? You guys watch the videos? It's going to help you understand. If you don't know. Well, what's the relationship between this long price and this result? If you do the inverse function, price is 15.5. Oh, you're reading the, okay. So if you use just the lawn price, this is all you can do. But if you invert it, so remember, when I did the interpretation in 4 for odometer, that was from log odometer to log price. And you can make this interpretation. When I had the interpretation of just log odometer, I was able to do this to price. But right now I'm saying I'm using a categorical variable. I'm using a categorical variable, and so this is different and long price. So I'm going to leave that, guys, to you. Robert's saying, oh, it's Robert here, is saying the price is 15.58% higher if it has a pink slip. Is that the interpretation? I'm going to encourage you guys to watch the videos and get the answer. It's all in there, and they build up. So I'm going to leave that to you guys to resolve, okay? But this would be just a literal interpretation, but remember, you're working with lawn price. I'm going to write here. Overall, from price rather than lawn price. Can you do it? Keeping in mind, long pink slip is not even significant, but that's what it's that's how you would interpret that. But because it's not significant, it's not a real effect, not a significant effect. Model. So I've shown you how to make most of the models, not the categorical one, which is the last one here, last set of models. So we got up to 5. He shows you or teaches you how to make the category. So we're in the categorical of the other variable. So he creates categories for age by looking at the graph from model 1. Well, if I plot age with price, remember I see the parabola, but he notices that the behavior, it's going like this. If you chop it up into bits, you have linear relationships in small ranges. Okay. So he exploits that and creates new variables, new categorical variables for groups of ages. So that can capture the change much nicer. Okay. So, or the relationship much nicer. So that's the 6th model. The 6th model. So this exercise with regression is very important that you have a knowledge of regression to perform a regression analysis in your research, to be able to read about regression. So if you haven't done this, you're going to have a good weekend working on it. And I encourage you, if you work together, it's fine, but you need to understand. So work on understanding, because you're going to have to replicate this for your papers. Sequential models, improving models. It turns out, you can try different things. Like right now, our model has a worse fit, but we're exploring these different variables right now. Okay. What you want to do is do a lot of modeling and then pick a few to present in your draft papers when we get there. Okay. So for the weekend, work on the modeling, and you're going to do it step by step with the videos. Okay, so I'm forcing you to watch the videos to get through it, because they're excellent, and they can be a resource after this course for you as well. Okay, any questions for me for the weekend? You're going to be working on this. I'm going to work on matching students. I'm going to give you some feedback on your homework that you've done so far. And then Monday, we will be in a new place, right? We'll all be caught up, and I'll be able to answer your questions. You guys will be paired up, and you'll have your partner, because you guys are going to have to critique each other for the following assignment. So each of you are going to have to talk about your research topic, critique each other, and prepare each other for your submission the following Friday. Right? I'm going to give you details on Monday about what I expect on Friday. I just gave you kind of an email. That's not enough. I have to give you a full assignment, like I've been giving you to date with these separate assignments. Okay, if you guys need me on the weekend, I am available. I'm available today to talk. Okay, so you're not on your own. You have each other and you have me. I'm at your disposal. I'm at your disposal. I'm not going anywhere. So let me know if you need me. All right? Okay. Have a good weekend. Ciao.